Hello and welcome back to Python Fundamentals. In this video, I'll explain about sympy, a Python library for symbolic mathematics. The sympy does all computations like simplifying expressions, solving equations, computing derivatives, limits, and integrals. So it consists of the functions for performing these operations like expand, limit, derivative, differentiation, integrate, factor, etc. And to import all the functions, we have to use keyword from simply import stuff. That is, we are importing everything from this library. Right? Execute, shift enter. And then so for using variables, suppose you are solving an equation and you require variables called x and y. So I want to solve the equation x plus y plus x minus y. So x and y are called variables. They are called symbolic variables. For that, you have to declare x and y as symbolic variables. For that, you have a keyword called, or a method called symbol of x. So this is x. Similarly, you can take another variable and declare it as a symbol. So we are considering x and y as symbols. And we are calling it with the method symbol method. Y. Right. Now, let us see some of the functions available in this library. The first function is will solve an equation by using which consists of x and y variables. So z is equal to x plus 2 into, the multiplication, you have to use asterisk, y, 2y minus, or you can write plus x minus y. So x plus 2y plus x minus y. So what is the result of this? 2x plus 2y minus y is y. So let us check the answer. So z to 2x plus y. So this is how you can use x and y as variables, right? And for multiplication, you all know these are the operators for addition, and this is the operator for multiplication. You know how to use them in an expression. So I just solved x plus 2y plus x minus y, which is nothing but 2x plus y. Next, we'll try to expand. We'll take an expression. We'll try to evaluate z is equal to, use the function called expand x plus y whole square, right? And power you have to do 2 asterisk x plus y whole square. You know the answer for this, x square plus 2xy plus y square. So this is expand. Now we can also use another method called, another function called simplify. We'll take the function, this one is sin x by cos x. Sin x by cos of x. So try to simplify and print. The sin x by cos x is tan x. So this is simplified. And then, so all these functions are available in the library called sympy, right? This is called symbolic mathematics. So now let us check for a limit, right? z is equal to, we take a limit sin x by x. Now we have to give the limits. For giving the limits, we can put comma, x tends to 0. That is, you have to put x comma 0. So you put sin x by x in brackets, sin x by x, and the limits of the equation is as x tends to 0. So x tends to 0, x comma 0. So here you have to give the function, and these are the limits, x tends to 0. So let us try to print. You know sin x by x is 1 as x tends to 0. Now, let us try to find series of a function. So z is equal to, we know what is series. Series of sin x with respect to x. Okay. Print z. So this is x minus x cubed by 6 plus x power 5 by 120 and so on. Similarly, you can find a series of cos x also. Cos x. You get here x and x cubed odd powers, and here we get even powers. This is the another function, and then we'll check differentiation. So simple differentiation, we know, is difference by diff is a differentiation function. Differentiation of log of x. Here you have to differentiate with respect to x, right? Log of x with respect to x. So with respect to x, you have to put comma and then write x. So we are finding differential of log s with respect to x. So d by dx of log x, it means, right? 1 by x. So that is the now we can also find z is equal to integration. We'll integrate sin x, sin function, sin of x. Now we have to give as x goes from the limits, right? So as x goes from 0 to pi by 2, we can use pi is also used when we use the symbol pi by 2, 0 to pi by 2, and find that in the result. Integral of sin x as x goes from 0 to pi by 2 is sin x. Then we can also find z is equal to, we can integrate x cube of x power x cube, comma, and then write as x goes from -1 to 1. Okay, integral of x cube as x goes from -1 to 1. What do you get? Obviously, you get 0 because integral of x cube as x goes from -1 to 1 is 0. That is called integration. And then we can find the factors also. So z is equal to, first give the expression, whatever you want to give. I want to find the factors of x power 4 minus 3 into x square. Square per square, we have to do 2 asterisks plus 1. Then to write x is equal to, that means you are storing the factors of in x, factors or z. Then try to print x power 4 minus 3x square plus 1. That is x square minus x minus 1 into x square plus x minus 1, because x power 4 minus x and plus x minus x square and minus 1 into minus 1 plus 1. So we can multiply and add and check whether we got the same expression or not. So that is the factor. So these are, you can also solve the simultaneous equation. So let us try to solve simultaneous equation, two equations. Take A is equal to solve x square minus 1 with respect to x. So let us try to solve and see, check the that is minus 1. So the roots of this equation are minus 1 and 1. So these are some of the functions available in sympy library. So it's just like a calculator. You can easily calculate integrals. You can perform expansion. You can simplify the expressions, and then you can find the limit. You can also find the differentiation, integration, and you can also find the factors. You can solve the equation and find the roots of the equation, and so on. I hope you all understood this simply. Thank you.